All right, this is lesson 22, and in this lesson, we're going to solve exponential equations, okay? We are solving exponential equations. And so when we look at, here's an example, if we look at this, we can see that it's an equation, it has an equal sign, and it is solvable because it has a single variable x, and any single equation that has a solution and has a single variable is solvable. And then these are the steps that are going to help us. Okay, so you can read through these steps. In fact, I recommend that you pause the video and go ahead and write out those steps in your notes. But we're just going to simply follow them as we go along. Okay. The first thing we want to look at in this particular example is we want the equation. Step one says to get the equation into this form, a to the power of b equals c. It has to be in that form in order to apply this procedure. In fact, it probably has to be in that form to apply almost any procedure. So what we have here is this is the a, so 3 is the a, and then x minus 2 is the b, and then it equals, and then 81 is the c. So this is already in the form that we need it to be. So we're going to go to step 2, and it says apply log base a. In this case, a is 3, so we're going to apply log base 3 to both sides of the equation. This is what that looks like. I'm going to do log base 3 of, and then I'm going to put this inside the logarithm. 3 to the power of x minus 2, close, equals, then I'm going to do log base 3 on the other side and put 81 inside, okay? So you can see we still have the 81, we still have the 3 to the power of x minus 2, but all we did was we took the logarithm of both sides. Okay, so now let's go to step 3. It says to bring the exponent to the front of the logarithm. So what we're doing is we're applying one of the properties of logarithms. So with this logarithm here, this exponent on the inside can be moved to the front of the logarithm. We're turning an exponent into multiplication. So we're going to move this x minus 2. So x minus 2 is going to go to the front. And now we'll just have log base 3 of 3. Okay? Because we got rid of the exponent and moved it over to the front. Now we'll just bring down the log base 3 of 81, okay? And then step 4 says cancel log base a of a. Well, remember, a in this case is 3. See, there's our a, 3. So what this is saying is cancel log base 3 of 3. And look, we have that right here, log base 3 of 3. This equals 1. Log base 3 of 3 is 1, so we can cross it out. And all we have left is this x minus 2. So now we have x minus 2 is equal to log base 3 of 81. Now we just solve for x. So we're going to try and solve for x here. So we're going to add 2 here. We're going to add 2 over here. This is going to cancel. And we're going to have x is equal to log base 3 of 81 plus 2. Now this log base 3 of 81, we can change that into the change of base formula. And we're going to have x is equal to, let me move that down a little more. X is equal to, and we'll have the natural log of 81 over the natural log of 3. This is the change of base, so this is the same thing as this, and then plus 2. Now we can key this into a calculator. So I'm going to go over now to the Desmos, or not Desmos, I'm going to go over to the NumWorks calculator. Okay, so we're going to open up the calculator, and we're going to type in natural log of 81, close parenthesis, then divided by natural log of 3. Then we press execute, and we can see that the answer is 4. And so now we know that this is equal to 4, so we'll have x is equal to 4 plus 2, and 4 plus 2 is 6. And so our answer is 6. Let's try another example. All right, so this is e to the power of 5x minus 1 equals 685. It is already in a to the power of b equals c form. Here's a, e is a, b is 5x minus 1 equals 685 is c. So we're ready to move on to step 2. Apply log base a to both sides. Well, a is e, so we're going to do log base e. Log base e is natural log. So we're going to do the natural log of e to the power of 5x minus 1 is equal to the natural log of 685. Okay? And now, step 3 says bring the exponent to the front of the logarithm. So we can take this 5x minus 1 and we can move it to the front of the logarithm. Okay? Now, I'm actually going to show you what we can do here is, we'll move the 5x minus 1 to the front, and then we'll do natural log of e, and then eventually we'll cancel e, and we'll have 5x minus 1. Okay? So I'm going to show you a little shortcut here that I use when I'm doing it without teaching it, and you can do it too. Really the net result is we can just, at this point, we can just cross out the natural log and the e and bring down the 5x plus 1. It saves a little bit of time, and a little bit of space on your paper. So you can just, that's ultimately what we're going to do. The net result is going to be we bring down 5x minus 1 and we cancel the natural log of e. So it's just a little shortcut. And then we'll bring down the natural log of 685. Okay. Now we're going to add 1 to both sides because we're trying to solve for x. So we want to get rid of this negative 1. We want to get rid of this 5. So we'll now have 5x is equal to the natural log of 685 plus 1. Now we divide by 5 on both sides, and we cancel here, and we have x is equal to the natural log of 685 plus 1 over 5. And what I'm going to do now is I'm going to do the natural log of 685 in the calculator, then I'll add 1 to it, and then I'll divide by 5. Okay? So let's switch over here to NumWorks. And so I'm going to do the natural log of 685, okay, press enter. Then I'm going to take my answer and do plus 1, enter. And now I'm going to take my answer and I'm going to divide it by 5. And I wind up with 1.506 rounded, okay? So this is going to be x is equal to 1.506, okay? Let's try another example. All right. So we have something new introduced in this example. This is not in the correct form. Whoops. It's not in the correct form. We need a base, an exponent, an equals, and then a number on the other side. We have a base, we have an exponent, we have an equals, we have a number, but we have this extra 10 lying around. We got to get rid of this 10 first. Well, this 10 is being multiplied by the 2 to the power of, so be careful, this whole thing is one thing, and exponents come before multiplication. So we cannot multiply the 10 times the 2, can't do that. We actually have to get rid of the 10. But since it's being multiplied, we can divide by 10, and over here we can divide by 10. And so that cancels the 10, and now we have 2 to the power of x minus 3 equals, well, 310 divided by 10 is 31. There we go. And now we're in the correct form. Now we're going to apply log base 2 to both sides. We're going to do log base 2 of 2 to the power of x minus 3 is equal to log base 2 of 31. Over here, we're going to cancel the log base 2 of 2. We're going to bring down the x minus 3. X minus 3 is equal to log base 2 of 31. Almost done. Add 3 to both sides. Add 3. And x is equal to log base 2 of 31 plus 3. Now this, I need to do a change of base so that I can find out the numerical value of it. So I'm going to have x is equal to the natural log of 31 over the natural log of 2, and then I'm going to add 3 to it. Now I'm going to go over to the calculator, and I'm going to do the natural log of 31, and then divided by the natural log of 2, and then press enter or execute. Then I'm going to take my answer, and then I want to, let's see, what is it, 3? Yeah, I want to add 3 to it. So plus 3, execute, and I get 7.954. 7.954. Okay, so x equals 7.954, and we're done. All right, let's try a few more examples. All right, look at this one here. We've got 1.14 to the power of 2x plus 3 equals 20. So we are in the correct form already. So now we're just going to apply log base a to both sides. A is 1.14, so it's going to be log base 1.14. We're going to have log base 1.14 of 1.14 to the power of 2x plus 3 equals log base 1.14 of 20. And over on the left side, we're going to cancel out the log and the 1.14. We're going to bring down the 2x plus 3. So 2x plus 3 equals log base 1.14 of 20. Now we're going to solve for x. So we'll subtract 3 from both sides. And we get 2x is equal to log base 1.14 of 20 minus 3. Then we're going to divide by 2, cancel on the left, divide by 2, and we get x is equal to log base 1.14 of 20 minus 3 all over 2. Now we're going to convert that logarithm into change of base so we can get a number. So we'll have natural log of 20 over natural log of 1.14 minus 3 all over 2. Okay, so let's do this one thing at a time. We're going to do the natural log 20 divided by natural log 1.14. Then we're going to subtract 3 from that. Then we're going to take that answer and we're going to divide by 2. All right, so let's do natural log of 20, close, divided by natural log 1.14, close, press enter. And then we're going to take that answer and we're going to subtract 3. Okay, then we're going to take that answer and divide by 2. And we get 9.932 rounded. Okay, so x is 9.932. Okay, all right, just a couple more of these. All right, look at this guy. Mr. Ryan figured out how to put a quadratic in an exponent. He figured out how to make an exponential equation include a quadratic. Isn't that awesome? All right, we're already in a to the power of b equals c form. We got a, this whole thing is b equals c. So let's apply our logarithm. So we'll do log base 3 of 3 to the power of x squared minus 8x plus 19 all equal to log base 3 of 81. Now I happen to know that this is 4. We actually did one like this, our first example. We know that log base 3 of 81 is 4, but you could do it in the calculator too. So over here, log base 3 of 3 is going to cancel. We're going to bring down the x squared minus 8x plus 19 is equal to, and again, you could do this in the calculator as natural log of 81 divided by natural log of 3, but I'm telling you the answer is 4. Okay. So now we're going to solve for x. We're going to subtract 4 from both sides. Why? Well, this is a quadratic, so we want to set it equal to 0. That's how we solve a quadratic. Okay, and we'll have x squared minus 8x plus 15 is equal to 0. Now this quadratic is factorable. There are two numbers that multiply to positive 15 and add up to negative 8. They are negative 3 and negative 5. So I'm going to put an x in front of each one of them, put some parentheses around them, equals 0. So x minus 5 times x minus 3 is equal to this, and it's equal to 0. And now we know what to do with this. We just take each one of these factors and set each one equal to 0. So separately, we'll do x minus 3 equals 0 and x minus 5 equals 0. Over here, we'll add 3 to both sides, and we get x is equal to 3. That's a solution. Add 5, we get x is equal to 5, and that is a solution, and we're done with that one. Okay, let's try another one. All right, this one's a little weird. You can see that it is definitely not in a to the power of b equals c form. Okay, we've got a subtraction here that really wrecks things. We can't subtract this from this because they're not like terms. So where do we go from here? Well, this one's a little tricky, okay? Let me tell you the first thing I'm going to do is I'm going to rewrite e to the 2x power, and I'm going to show you how I'm going to rewrite it, and then I'll explain it. This is the same thing as e to the x power in parentheses, then squared. Because remember, when we take something to an exponent and in parentheses, then raise it to another exponent outside, we multiply the two exponents. So 2 times x is 2x. So this is e to the 2x power. This is also e to the 2x power. So this is equivalent to this. Now we're going to write this part, minus 7, and I'm going to put the e to the x inside parentheses, e to the x. Why? Because we have another e to the x in parentheses over here, and we might be able to do something clever with that, okay? And that's going to be equal to 18. And so now what we're going to do is we're going to do a little bit of substitution, okay? We're going to make a statement. We're going to make something up. We're going to say that u is equal to e to the x power. And it's okay. I know there's no u anywhere. We made this up, and it's going to make things a little bit easier for us to understand. We're going to replace all the e to the x's with a u, okay? So here, I'm going to take e to the x out, and I'm going to put in a u right here, okay? So I'm going to have u squared minus 7, and I'm going to replace this also with a u, okay? Minus 7u equals 18, okay? You'll understand this in just a second. Now we'll subtract 18 from both sides. What we now have is u squared minus 7u minus 18 is equal to 0. This is a factorable quadratic. It's u to the second power. And now we just need to find, are there two numbers that multiply to negative 18 and add up to negative 7? There are. They are negative 9 and positive 2. So we're going to have here u minus 9 times u plus 2 equals 0. And now what we can do is we can now replace each of the u's with e to the x power. So now we have e to the x power minus 9 times e to the x power plus 2 equals 0. And now what we would do is we would take each of these two factors. We now have two factors. We would take each one and set it equal to 0, except that e to the x cannot equal 0, and therefore e to the x plus 2. If we add 2, so e to the x is going to be a positive number. E to the x is always a positive number. No matter what you plug in for x, the answer is going to be a positive number. Plug in a 0, you get 1. Plug in 1, you get e. Plug in negative 1, you get 1 over e. No matter what you plug in, it's a positive number. So if we add 2 to a positive number, then this is always going to be a positive number. And therefore, we cannot set this equal to 0. So if this cannot be equal to 0, then this must be equal to 0. And it can be, because it has a negative 9 in it, okay? So we're just going to now say e to the x power minus 9 is equal to 0. Then we're going to add 9 to both sides, and we get e to the x is equal to 9. And now we can apply the logarithm to both sides. We can now do the natural log of e to the x is equal to the natural log of 9. Cancel the natural log of e, and all we have left is x equals natural log of 9. So let's put that over here. X equals natural log of 9, which we can just plug into the calculator. We can do natural log of 9. So that's 2.197. So x is equal to 2.197. All right. We have just one more example to do. All right, this one's a little crazy because we have two exponential bases, 5 and 2, and two exponents, okay? It would be nice if the exponential base was the same on both sides, but it's not. And so we're just going to have to do it as is. It's not really in the form a to the b equals c, but if we call 5a and 3x minus 7b, we can make do by calling 2 to the power of 4x plus 5 c, but it'll be a little messy. So let's go ahead and do this. It's going to be a little messy, okay? We're going to apply log base 5 to both sides. So we're going to do log base 5 of 5 to the power of 3x minus 7 equals log base 5, not log base 2, has to be log base 5 because we have to do the same thing to both sides. Log base 5 of 2 to the power of 4x plus 5. Now on the left side, we can just cancel the log base 5 of 5 and bring down the 3x minus 7. But over on this side, we cannot cancel log base 5 of 2 because that does not equal 1. Therefore, we have to keep the log base 5 of 2. What we can do is move the exponent, 4x plus 5, we can move that to the front of the logarithm. So that's what we're going to do. We're going to put 4x plus 5 at the front of the logarithm, log base 5 of 2. So this log base 5 of 2 is now just a number. You could key that into a calculator and it'll give you a number, a decimal number, an irrational number. Okay? So because it's a number, this can actually be distributed to the 5 inside the parentheses, and it can also be distributed to the 4x inside of the parentheses. It's going to be messy, but it can be done. So now we're going to have 3x minus 7 equals. We're going to distribute the log base 5 of 2 to the 4x, and we'll have 4x log base 5 of 2. Then we have plus 5, plus 5, and now we have to distribute the log base 5 of 2 onto the 5, log base 5 of 2, okay? Like I said, it's a little messy. Now what we're going to do is in order to solve for x, we need all of the x terms, anything that has an x in it has to be on one side. So I'm going to move this 4x log base 5 of 2 over to the left side, and then everything that doesn't have an x, like this minus 7, I'm going to move over here to the right side. So I'm going to add 7 to both sides, add 7, and I'm going to subtract 4x log base 5 of 2. This is all one number. This is all one thing. I'm going to subtract that from both sides. Minus 4x log base 5 of 2. Okay? The negative 7 is going to cancel. And then over on the right side, this is all going to cancel. Okay? And so all we have left on the left is 3x minus 4x log base 5 of 2. And on the right side, we have 5 log base 5 of 2 plus 7. So 3x minus 4x log base 5 of 2 equals 5 log base 5 of 2 plus 7. Okay? And then what we're going to do is these x's, each term, there's two terms here, this one and this one, each one has an x in it. So I'm going to factor out an x. I'm going to remove the x's from inside. So I'm going to divide out an x. That's going to leave me with 3 minus 4 log base 5 of 2. Okay, and that's going to be equal to 5 log base 5 of 2 plus 7. Now, to solve for x, I just divide. I'm going to divide by 3 minus 4 log base 5 of 2. Same thing on the other side. Divide by 3 minus 4 log base 5 of 2. There we go. And then on this side, this cancels out. And all I have left is x equals this monster. Okay? But this monster can be plugged into a calculator. Okay? Especially if we change it into do the change of base. So 5 log base 5 of 2 will be 5 times ln of 5 over ln of 2. That's sorry, I did it wrong way around. Let me try that again. It's going to be natural log of 2 over natural log of 5. Sorry about that. Okay, and then plus 7. So here's the 5. Here's the log base 5 of 2, and then here's the plus 7. Going to do the same thing on the bottom here. We're going to do 3 minus 4 times log base 5 of 2. So that is going to be natural log of 2 over natural log of 5. There we go. And if I key this in a calculator, I'll get a number. So let's do that. Let's see here. We're going to make it a fraction. 5 divided by 3. I'm going to go back up into the numerator, and I'm doing 5 times, and I'm going to put this change of base in parentheses. Natural log of 2 divided by natural log of 5. There we go. Then I'll close this one off. Then plus 7. Down here we'll do 3 minus 4 times, parenthesis, natural log of 2 divided by natural log of 5, okay? And this is the whole thing. You can go back and look at your notes, and this is exactly what we had. So now we're going to hit execute, and we get 7.166. So that's the answer to this. X equals 7.166, okay? All right, so there's about 7 examples of how to solve exponential equations.